This is the only video you need to learn and master stoichiometry calculation in chemistry. I want to assure you one thing. By the time you finish watching this video, you'll be able to what? Solve all the problems you come across when it comes to what? Stoichiometry calculation. Finish watching this video here and you find stoichiometry calculation difficult for you, then I bet you I'll give you go ahead, unsubscribe to my channel and never watch my video again. Do you understand? So that is the guarantee I'm giving to you. So I'm going to show you a simple method you can use in solving stoichiometric calculation. So make sure you watch the end and take down every single thing. If you have any question, always leave it at the comment section. I will respond to every single of your questions. Do you understand? Let's get into it. So we are going to start. We are going to solve a lot of problems. We are going to solve a lot of problems so that you know how this question will be set, and I can easily tackle them. You get. So, but therefore, let's find what is stoichiometry. What do you understand by stoichiometry? So take it down. Stoichiometry in chemistry is the study of the quantitative relationship between the reactant and product in a chemical reaction. It allows chemists to predict how much of each substance is needed or produced in a chemical reaction. So in the sense that what about stoichiometry is what is quantitative relationship between the reactant and product. Do you understand? So it tells how much of a substance you need to produce a product, or how much of a product is being produced when you react the reactants. So that is everything about stoichiometry. So stoichiometry is stoichiometry. When it comes to stoichiometry, it is used to calculate the amount of the product produced or the amount of the reactant needed to produce certain amount of product. So in the sense that if you want to really solve stoichiometry calculation, the first one to know is it's a balanced chemical equation. And in chemistry calculation, we have different ways, we have different formats, we have different methods in solving chemistry calculation, especially on stoichiometry calculation. But in this video here, I'm going to give you a simple method you can use to solve stoichiometry calculation. If you can master what I'm about to teach you now, stoichiometry calculation will be more easier for you. Just no matter how complex the question look like. So now let's take a look at what these two questions. These two questions is a very good start when it comes to stoichiometry calculation. So please follow me closely as I explain to you. So here we have phosphorus born in oxygen according to the equation P4O5, P4O, give you a P4O10. Then it's phosphorus born in oxygen to produce phosphorus oxide. Do you understand? So this is what balanced chemical equation. So in the sense that the balanced chemical equation has already been given to us. So in the sense that we don't need to stress ourselves again to get the balanced chemical equation. It's already been given to us. Unlike this question, you will say how many grams of HBr, hydrogen bromide, will be exactly be required to react with 2 grams of propane. You can see that this one is not, they don't give us the balanced chemical equation here. That we have to write a balanced chemical equation. But now let's start with this guy here. Solution. Please watch me here as I explain to you. I will show you simple way for you to be able to solve this kind of problem when we see it in the exam. So the first step is to do what? Is to write the balanced chemical equation that have already been given to us. Like I said, in the balanced chemical equation was not given to you or is not given to you in the question, you have to write out the balanced chemical equation, and I'm going to show you when we get to this point here. So now here we have P4 plus 5O2 giving you P4O10. This is that. Now after you have written this one here, the next one to do is to write the balance mole, balance mass, and balance volume. So here we have mole, mass, and volume. Do you understand? So you have to write the balance mole, the balance mass, and the balance volume. So the question will now be, how do we get it? The mole is very easy. From your balanced chemical equation, you get your mole. Here we have, remember, here we have 4 atoms of phosphorus, 4 atoms of phosphorus here. Here we have 10 atoms of oxygen. Here we have 10, so it's balanced, right? So how many moles do you have here? You have 1 mole. Right there, 1 mole. How many moles do you have here? Here we have 5 mole. Right? How many moles do you have here? Here we have 1 mole. Do you see that? Now, how do we get the mass? The mass is very easy. Calculate the molar mass of this compound here, multiply what with the numbers of moles. Just as easy as that. Calculate what the molar mass of each of the compound and multiply it with what numbers of moles here. So here we have phosphorus P4, right? What the atomic mass of phosphorus? It was given to me to be what 31. So these are constants. So the atomic mass of phosphorus is what is 31. So it's going to be 31 times what 4, right? So which I'm going to have what 124 gram per what per mole, right? So now remember, how many moles do we have here? 1, right? 1 times 124. It's going to be what 124 gram. As easy as that. It's not difficult. Now for oxygen, here we have O2. Oxygen is what is 16, right? So it will be 16 times 2, right? 16 times 2. Here we have 32 gram per what per mole. But understand that how many moles do we have here? Here we have 5. So 5 times 32. So it will be 32 times what? 5. Here we have 160 gram. Can you see that? 160 gram. Hope you understand. So 32 times 5, 160 what gram. As easy as that. Now let's look at what P for O10. P for O10. Here we have what? Here we have 32 times 4 plus what? 16 times what? Times 10, right? So let's do the calculation here. Here we have 32 times 4 plus 16 times 10. Here we have 288 gram per what per mole, right? Now remember, how many moles we have? Here we have 1 mole. 1 times 288. Here we have what? 288 gram. Can you see that? As easy as that. So I've got to what my mole for each of the species. I've got to what my mass for each of the species. Now, how do I get my volume? It's very easy. It's very easy. Understand that. Now, understand that 1 mole of any gas at STP, 1 mole of gas at STP is always equal to what? 2.4 dm cube. Do you see that? 1 mole of gas at STP is always equal to 2.4 dm cube. Now, for the sake of this calculation here, I'm going to do for every single thing here. Yeah, how many moles do you have here? Here we have 1 mole. 1 times 2.4. Here I have what? 2.4 dm cube, right? Now here we have 5 times 2.4. Here we have 112 dm cube, right? Here we have 1 times 2.4. Here we have 2.4 dm cube. Now let me say this here. Once you are able to get this, we have solved almost 60% of the problem. I'm telling you the truth. Once you are able to do this thing here, 60% to 70% of the problem have been solved. So step 1 is to write a balanced chemical equation. Step 2 is to write what the balance mole, balance mass, and balance volume. These are what we are going to use in our calculation. Now let's move to the next step. What is going to be the next step? The next step is to what? There's no space here again, so I'm going to write continue from here. Now the next step here is to what? Write out the species I'll be giving and what I will be looking for and look for the relationship. I'll be explaining that for you in a moment. Now look at something here. Now if you look at the question here, it's that how many liters of oxygen will be required at STP to complete oxidation of 12.4 gram of phosphorus? If you look at the question here, they say liters of oxygen, and liters is what is volume. What they're asking us to look for is what is volume of what? Of O2. That's what they ask us to look for, right? Volume of what? Of O2, oxygen gas. That's what they look for. They say you should look for. Now they gave us 12.4 gram of phosphorus, right? So mass of what? Of P4 was given to me to be what? 12.4 gram. Hope you understand. So these are the things that we need this one, we need this one here. So what do you want to do here? You want to write out the relation between mass of P4 and volume of what O2 from this balanced chemical what equation here. So here we have our gram. So if you come here we have gram, right? So that would be from balance equation here, from the balance equation, mole, mass, and volume. You find that the mass of phosphorus is what is already what 124 gram, right? So you cannot say from the balance, what equation, for the word balance equation, right? Here we have 124 gram of what P4, right? Is equal to, now look at what O2. They say volume. Look at volume here, right? Volume of O2, which is oxygen gas, is what 112 dm cube. Like you know how got from here, right? So now going to be 112 dm cube of what O2. Hope you can see that. Look at it here, right? Now, how do we now combine them together? Remember, we are looking for what the last step. Now, this is the last step. This is what the final step. Now, the last step is to calculate the volume of O2 using this guy. Just now, so this, as easy as it is, just watch out. This is what is the last step, right? So remember, we are going to put question mark here. Now, why we put question mark here? If it's what, because we are looking for this guy here. So going to be question mark volume of what of O2 equals to, now they gave us the mass of phosphorus, which is what 12.4 gram of what P4 over what 1. I'm going to say times. I'll put a division sign here. You understand? This is where I'm not going to use this guy here. Now, the last step is this. You must arrange it in a way you need to cancel out units. Let me explain to you. It's very easy. Now, gram of P4 is already at the top. This guy will go to the down. Why is it be at the top? Now, yeah, I'm not going to have 112 dm cube of what O2. Then this guy will come to the down. Here we have 124 gram of what of P4. So if you check it very well, this we can also add this one here. So the main reason why this guy is coming to denominator, why this guy is moved to denominator here, is because so that this will what we eliminate this one here. What am I going to have left is what dm cube of what O2, which are what looking for. Hope you understand now. So it's not going to be 12.4 times 112 dm cube over, here we have 124. So what I want to do here is what use the calculator to get your answer. So we have 12.4 times 112, right? Divided by 124. So you're going to be 11.2 dm cube. That is the word answer. 11.2 dm cube. As easy as that. Just please, if you understand, leave a comment section that you understand. And if you are following this class here, please leave a comment section that you are following this class. It's very important I hear from you. Now, if you have any question, leave it at the word comment section. So that is for what this class. That is for what for this question. So let's move over to what is second question. Let's move over to the what second question. Question 2. Now getting the balanced chemical equation will be our issue, but I'm going to explain to you. So solution is that how many grams of hydrogen bromide would exactly be required to react with 2 grams of propine. Propine is an alkyne. Is an alkyne, right? And the general molecular formula for alkyne is what is CnH2n-2, right? Now what about propine? Prop means what? The numbers of carbon atoms is 3. So if you fix 3 here, so it will be C3H23 minus 2. Can you see that? So it's going to be C3H. 2 times 3 is what is 6. Minus 2 is what is 4. So you have C3H4, right? So instead that C3H4 is reacting, because look at something here, say how many grams of HBRO will exactly be required to react. So propine is reacting with this one here to produce a product. So that's going to be C3H4 plus what? HB what? RO. Can you see that? So that is they ask here, how many gram do you need to react with what 2 gram of this one here? That is the question. Hope you understand. That is the question. So what will that be product you are adding? Because when propane react with what hydrogen bromine, it's called addition what reaction. Now let me just give you a tip of the iceberg here. You have C3C hydrogen. So this is what is propane having what a triple bond. So when you react what HBRO, what I want to do here, this one will be added here, this guy will be added here. You have now CH3C, you have now what BRO, double bond CH2. Now, if you check what their molecular formula is going to be 1, 2, 3, C3H H5 B what R. So is when these two react together, you have what C3H5 B what R. Now, if in case you don't understand, so this is under organic chemistry. It's under what reaction of the water kind addition reaction. So I'm not talking about that one here. But understand that how to get your product. When you add this together, you get this one here. So that is what the first thing you want to do here. Write out what a balanced chemical what equation. That is what the first thing. Write out what a balanced chemical equation. Do you understand? Write out what a balanced chemical equation. Now, this what to do here is what write out what the balanced mole and balanced mass. So I can just say mole, mass, and what and volume. I'm going to show you simple way to actually solve this in here, right? Because once you master this method here, you can boycott some process, right? But I want to understand this before I show you those things. So how many moles do you have here? You have 1 mole. Here we have what 1 mole. Here we have what 1 mole, right? Now, if you check this question here, they did talk about volume. So volume is not really needed. So you bring in volume here is just a waste of time, right? Because they did say anything about volume at STP, so you ignore this part. So it's not needed. So you only need mole and what and mass. Just now let's get the mass of this and this. So what is molar mass of C3H4? C3H4. What is molar mass? Going to be what 12 times 3, right? Plus what 1 times 4. Can you see that? So what do you have here? 12 times 3 plus 4 times 1. Here we have what 40 gram per watt per mole, right? How many moles do we have here? We have 1 times 40. Here we have 40 gram, right? Look at what HB what RO. We're going to be what 1 times 1 plus what 70, 80 times what 1. We're going to be what 81 gram per watt per mole, right? So 81 gram per watt per mole, right? How many moles do you have here? We have 1 times 81. Here we have what 81 gram, right? The same thing here, C3H5BRO. C3H5B what RO, right? So what to be what 12 times 3 plus 1 times 5 plus 80 times 1, right? So what do you have here? Here we have 12 times 3 plus 1 times 5 plus 80 times 1. So you have 120. So it's going to be what 121 gram per watt per mole, right? So that is 1 times this one here. You have 121 gram. That is it. Now, like what I said, there's no point of us saying the volume here because they didn't say anything about volume at SCP. So you include the volume at SCP here, just like wasting your time because you're not going to use it. So now let me write this place out. So once you have done this for here, understand that immediately you finish doing this one here, you have solved almost 60% to 70% of your problem. You understand? By doing this here, you have eliminated almost 80% of your issues. So now let's understand the question first. Let's ask, how many grams of HBr, hydrogen bromide? So they're asking to work out, calculate mass of hydrogen bromide. So mass of hydrogen bromide, be what they say she will look for, right? Now, would exactly be required to react with 2 grams of propane. So mass of what? Propane, which is what? C3H4 is what? 2 what gram, right? If you check very well, they are talking about mass and mass, right? Mass and mass. So it's going to be mass and mass. Hope you understand. So they gave us mass of this guy here. Now what is mass of propane here in the balance equation? 40 gram, 40 grams. So it's going to be 40 gram of what? C4, C3H4 is equals to what is the amount of gram here? Here we have what? 81 gram. 81 gram of what? H what B R. That is it. So this one is what is for balanced chemical what equation. So the last step is to look for what? The mass of what? Of HBr now. So this is what I'm going to be question mark mass of what? HBr, right? Equals to what will we give? We will give what? 2 grams of what? Propane. So going to be 2 grams of what? C3H4 over what? 1 times. So now let me ask you here, which will be at the top, which will be at the down? Let me ask you here, which will be at the top, which will be at the down? Take. So here we have 40 grams of C3H4 equals to 81 grams of HBr, right? Now, which will be at the top and which will be at the down? Now, gram of C3H4 is already at the what top here. You have to bring this one to the what denominator. So here I'm going to have 40 grams of what? Of C3H4. Right there. They have what? 81 grams of what? Of HB what R. You can see that this and this want to cancel out. What you have here is what is 2 times 81 grams of what? HBr over what? 40. So here I'm going to have what? 2 times 81, right? Divided by what? 40. Here I have what? 0.05 gram. That is what? That is the what answer. This is as that. So we still have more problem to solve. Let's move to the next set of question. Now let's look at what the second set of questions. And this second set of questions are very, very confusing. A lot of students do have problem with this question. So now let's look at the question here. Let's see that how many grams of hydrogen will be liberated when 6 grams of magnesium ribor dissolve in 500 cm3 of 6 molarity HCl? Now here we have at STP, how many liters of hydrogen will be obtained from the reaction of 500 cm3 of 0.5 molarity H2SO4 with excess zinc metal. Now, this is one of the most confusing questions when it comes to what chemistry calculation. As a matter of fact, I regard this question as one of the most difficult questions when it comes to what chemistry calculation. Now, this question is under limited reactant and reactant in excess. So as we move on, I'm going to show you how to solve this problem here. And I'm going to walk you through step by step on how you can solve this problem here. Now, before I continue here, I have created a complete PDF guide on how to solve this problem here. So after this video here, please request for the PDF on this topic and I will send it to you. So to get a free PDF here, you only leave a comment section that you need a PDF. But therefore, like and subscribe. Then leave a comment section that you need a free PDF. Then I will send it for you for free. You are going to take all the steps, step 1, step 2, step 3 on how to solve this kind of problem. Do you understand? But let's get into it first. So the first one to do here, remember that in stoichiometric calculation, you must therefore write a balanced chemical equation. For this question here, the balanced equation was not given to us. So now let's see how we can get a balanced chemical equation from here. This is how many grams of hydrogen will be liberated. That asks you to calculate the mass of hydrogen that will be liberated when 6 grams of magnesium ribor. Magnesium, so first we start with magnesium ribor. Solution. So we first start with magnesium reball. So magnesium reball is what is magnesium metal. So there is Mg, right? Right there. When 6 grams of magnesium reball dissolve, then it reacts with hydrogen chloride plus what? HCl. Now what happen here? They will occur here. Now displacement reaction will occur here. Magnesium will displace hydrogen. Just that magnesium will displace hydrogen. So you have to get MgCl2 plus what? H2. Now this under writing of chemical equation or predicting what? Chemical what reaction. I don't want to go into this one now because I don't want this video to be too lengthy, but this is what is a what this is what is a the chemical what reaction. So now when magnesium reacts with hydrogen chloride, we're going to produce what? Magnesium chloride plus hydrogen gas. Do you understand? Now they're asking you what is the mass of hydrogen gas that is what liberated. Do you understand? So now once I've written this one here, first of all, let's balance the chemical equation. Here we have one magnesium, right? One hydrogen. Here we have 2 hydrogen. So you have to put 2 here, right? Do you understand? Now then it is what balance. So this is what is balance, right? So this is the first thing I want to do here. Once the question is given to you, the first thing I want to do here is what to write out a balanced chemical equation. So this is what the first thing. Do you understand? Now look at the question. Now look at what ability what the balanced chemical equation. The next thing we want to look at is what, so look at what those parameters given to us. Now is that when 6 grams, so mass of what? Magnesium was given to me to be what? 6 what? Gram, right? Now you say that dissolve in 500 cm cube of 6 molarity HCl. Now please pay attention here. Now volume of what? HCl is what? Volume of HCl is what? Is 500 cm cube. Do you understand? Now molarity of HCl, molarity of what? HCl is what? Is 6 what? Molarity. Do you understand? Now please pay attention here. Now we have to use these two to calculate mass of what? Hydrogen what? Chloride. Just so they give us mass of this one here. So if you say that, please pay attention here. They're asking you what is the mass of this produced when 6 grams of this react with how many grams of this one here. Do you understand? So now how do we get the mass of this guy HCl? Now this way you have to what? Use what? Because they gave us what? We want to use this parameter to get what? Mass of HCl. Just a mass of what? Of HCl. Just that. So how do we get the mass of HCl? Now in my mole constant calculation, I've given you a simple formula that can explain that for you. Remember, in our last class, when it comes to mole concept calculation, where I gave all the formulas. Please, if you have not watched that video, we are talking about mole concept, because that mole concept is a foundational calculation to any other chemistry calculation. So please, if you have not watched that video, please go and check out that video on that mole concept or calculation. So in that video here, I gave what a formula that said that mole equals what? Mass, but what? Molar mass equals what? Concentration times what? Volume. You see that? So that this is what I'm going to use to calculate what? The mass of what? Of HCl. You know the reason why? They gave me what? The concentration of HCl. I know what? My volume, right? I can calculate what? My molar mass, right? I can really get what? My mass. This that. So I will continue from here. Just I will continue from here. So now the idea now is to get mass of HCl. How do we get the mass of HCl? It's very, very easy. Yeah, mole equals to what? Mass over what? Molar mass equals to concentration times what? Volume. Just that. So now if I should what? Make mass the soil formula here, I see what? Mass equals to concentration times what? Molar mass times what? Volume. Do you see that? So now what is my concentration? My concentration is what? 6 molarity. And molarity is mole per dm cube, or what? Mole per liter. So instead that, because volume must always be in what? Dm cube, I'm going to convert this CM cube to what? To DM cube. And let me ask you here, how do we convert CM cube to DM cube? How do we convert what CM cube to what? To DM cube? Now, whenever you see CM cube here, I want to convert to what? To DM cube. Divide by what? 1000. Do you understand? So to convert CM cube to what? DM cube, what I want to do here is what? Divide by what? 1000. If you should divide it by 1000, you have what? 0.5 what? DM cube. Do you understand? So that is the volume is okay. We know what our molar mass here, which is concentration here. That is, I know what my volume and my concentration here. The next one I want to do is to calculate the molar mass of what? HCl. So how do you calculate molar mass of HCl? So going to be molar mass of what? Hydrogen what? Chloride. Do you understand? It's very easy. Now, the atomic mass of hydrogen is what? Is 1. How many atoms of hydrogen do you have here? 1. So going to be 1 times what? 1 plus. Chlorine is what? Is 35.5. 35.5 times what? 1. So everything going to be what? 36.5 gram per what? Per mole. This is that. Now the idea is that let me get the mass of HCl. So the mass of HCl, now mass of what? Of HCl is equals to what? Concentration is what? Is 6. So going to be 6 times. Molar mass is what? Is 36. 36.5 times volume is what? 0.5. 0.5 is okay. So now what I want to do here, so we'll say 6 times 36.5 times 0.5. You now have what? 105.5, right? Gram. That means I have used all this volume of HCl, molarity, right, and the molar mass to calculate what? Mass of HCl. Do you understand? So the mass of HCl that reacted what? With 6 grams of magnesium is what? Is 109. Please understand this here, because for we to calculate what the mass of this guy liberated, I have to use these values here to calculate what? Mass, so that it can be mass to mass. So now I've already calculated what the mass of HCl that reacted what? Mass of what? Magnesium ribbon, right? So since I've got this one here, I'm going to wipe everything out. So all these ones are not needed again. I'll just write out mass of what? HCl is equals to what? It's going to be what? 109.5 gram. This is that. So I'll wipe this one out. This is where the calculation now starts from. Now this is where the calculator starts from. Now the next thing we want to do here is to write what? The balance mass and what? Balance mole. This is so I want to what? Write to out, or let me just write on here. Mass of what? Magnesium is equals to what? 6 gram. Then mass of what? HCl is equals to what? 109.5, right? Now let me just remove this one here. So now let's start what? With the calculation now. The idea is what? Is what? Calculate the mass of this one, right? So that let's write our balance mole, our balance what? Mass. Remember, they did say anything about volume, so we are going to ignore volume. Do you understand? So it's going to be mass. No, going to be what? Mole. I'm going to have what? Mass, right? Now, how do we calculate the mole? How do you get the mole? Is what? Is the balance coefficient. Just that 1 mole, 2 mole, 1 mole, 1 mole, right? So it's going to be what? 1 mole. Here we have what? 2 mole. Here we have what? 1 mole. Here we have what? 1 mole. This is that. Now, how do you get the mass? The mass is the what? The mass is the molar mass of the compound times 1 mole times mole here, right? So, the atomic mass for magnesium, the atomic mass, because it's just one, that's why it's called atomic mass, right? Why it is a compound, it's called what? Molecular what? Mass, or what? Molar what? Mass. Do you understand? So we're going to do what? 24 gram per mole, because the atomic mass of magnesium is 24 gram per mole. It was given to us. So 24 times this one here, we have what? 24 gram, right? HCl. Remember, HCl, we have already calculated HCl to about 36.5, right? So 36.5 times 2, here we have what? 73 gram, right? Now this one here, 35.5 times 2 plus 24. Here we are what 95 gram. Can you see that hydrogen is what is 1 times 2, so going to be what 2 what gram. Can you see that? That is it. So it is saying that, please pay close attention. This is where I want to explain to you now. Now, it is saying that I'm going to go to what my balance mole, I'm going to what my balance mass, right? If you check it very well, they gave us what mass. If you check it very well, mass of what of magnesium was given to us to be what 6 what gram, right? Now, mass of hydrogen chloride, mass of what hydrogen chloride was given to me to be what 109.5 what gram. They're asking us what is the mass of hydrogen gas liberated. So mass of what H2 liberated, this is what we are looking for. Do you understand? So how are we going to do that now? How are we going to do that? This is where, please pay close attention here. I want to explain to you step by step so that you get the concept. Now, how are we going to do this here? Now, therefore, use the mass of magnesium to calculate what mass of what hydrogen. Just so use what mass of magnesium to get what mass of what hydrogen. After you have done that, you now use what mass of what hydrogen chloride to calculate what mass of what hydrogen. Once you have done that, before I'm not show you what to do. Do you understand? So how do we use mass of magnesium to calculate what mass of hydrogen? Do you understand? So you can now say calculating mass of what H2 with what 6 gram of what 6 gram of what of magnesium. So now look at something here. So if you should relate it here, this and this, mass to mass. So mass to what to mass. So it will be mass to what mass. Now in the balance equation here, 24 gram of magnesium is equal to 2 gram of what of hydrogen gas. Do you understand? That is it. So for the balance equation now, you just write it out. Going to be what 24 gram of what of magnesium is equal to what 2 gram of what of hydrogen what gas. Do you understand? As easy as that. So now remember in our calculation here, we want to what get this one here. So going to be question mark mass of what H2 equals to. Now remember we are using what 6 gram of what magnesium. So going to be 6 gram of what magnesium over what 1 times. Do you know we are not going to use one here? Now magnesium 24 gram of magnesium will go to the denominator. Why 2 gram of HCl will go to the denominator, to the numerator. So going to be 2 gram of what H2 over what 24 gram of what magnesium. Do you see that? Now do you know the reason why? So that gram of magnesium cancel out gram of what magnesium. What am I left? What am I left with? 6 times 2 divided by 24. 6 times 2 divided by what 24. Here we have 0.5. So you have now 0.5 gram. What does it mean? It means that 6 gram of magnesium produce 0.5 gram of what of hydrogen gas. That is the meaning. Do you understand? So it means, therefore, so you can say what? It means, right? 6 gram of what magnesium produce or is equals to what? 0.5 gram of what of H2. This that. So in the sense that we have used what the mass of magnesium given to us to calculate mass of what hydrogen was liberated. Now the same thing here, we are going to use what mass of hydrogen chloride, to calculate mass of what hydrogen gas liberated. So the same thing that I have done here. We now say what calculating mass of what of H2 with 109.5 gram of what HCl, right? So what are the relationship? This is equals to this, right? So for the balance equation here, 73 gram of HCl is equals to what 2 gram of what H2, right? So going to be what 73 gram of what ACl is equals to what? Is equals to what? 2 gram of what? Of 2 gram of what? H2. Can you see that? 2 gram of what? Of H2. So the same thing here, you got to be what? Question mark mass of what? Mass of what? H2 is equal to, is what? Is equal to. Now remember, what is mass of HCl that we have calculated, that we calculated from this one here is what? 109. So going to be 109.5 gram of what? HCl over what? 1 times. Same here, 2 gram of H2 go to the top. So you have 2 gram of what? Of H2 over what? 73 gram of what? Of what? HCl. So what I want to do here, this will cancel out what? This. So you have now have what? So you have what? You have now have 109.5 times 2 divided by 73. You will now have what? 3 gram. You have 3 what? Gram, right? 3 gram of HCl. Now 3 gram of H2. So inside that, right? Inside, and what means? It means what does it mean? It means 109.5 gram of what? Of hydrogen chloride is equals to what? 3 gram of what? Of H2. Do you understand? Now, please pay close attention here. Yeah, we now have 2 here. So 109.5 gram of HCl produces what? 3 gram of what? H2, right? And 6 gram of what? 6 gram of what? Magnesium produce what? 0.5 gram of what? Of H2. Now, please take note here. Now, with this simple thing here, I can get what? My limiting reactants. I can get what? My reactant in excess. I can get the mass of hydrogen produced. Just now, this is one unique thing or good thing about this method about which I'm teaching now. Just now, this is what? The best method to solve limiting reactant and what? Reactant in excess. Because once you have gotten these two, right there, once you have gotten what? These two here, you can get 3 things at the same time. One, you can get what? The amount of the product produced or the amount of hydrogen liberated. Number 2, you can get what? Which of the species is limiting reactant. Number 3, you can what? Get the reactant in excess. Because when the chemical reaction occurs, when 2 things occur, let me just say this guy is reacting with this guy here, right? The chemical reaction. Now, as they are reacting, it will get to a point where the reaction will stop. The reaction will no longer proceed again, right? Now, when you get to a stage when the reactants, when the reaction can no longer proceed again, it means that one of the reactants have been used up. Just if, for example, you have A plus B to produce what? C. That is, we need these two to react together to produce what? C. Just now, if the reaction proceed and stop, it means that one has been used up. Just that reactant that is being used up is called limiting reactant because it's the one that is limited. Why the one that remain after the reaction have stopped is called reactant in excess. Do you see that? So now, why the amount of this one produced? The amount of the amount, please pay close attention. The amount of the product produced in a chemical reaction depends on the limiting reactants. Just that it depends on the limiting what reactants. Do you see that? And the limiting reactants produce what? The least amount of the product. Please take all this thing down. If you're not right, you just leave this video here. Now, the limiting reactants produce what? The amount is the one that will determine the amount of product produced. Let me say this again. The limiting reactant is the one that determines the amount of the product produced in a chemical reaction. And the amount of the product produced in a chemical reaction is always what? The least amount calculated. These are things into what? Pay close attention here. Now let me explain to you. 109.5 gram of HCl produces 3 gram of H2. 6 gram of magnesium produces 0.5 gram of H2, right? Now if you look at what? 3 gram of H2 and what? 0.5 gram of what? H2 here. This one is what is the least, right? So the amount of the product produced in a chemical reaction in this one here, the amount of hydrogen gas liberated in the chemical reaction is what? 0.5 gram. So you cannot say amount the mass of H2 liberated is equal to what? 0.5 gram. It's okay because it is what is the least amount produced in the chemical reaction. 0.5 gram. Hope you understand. Now, the reactants that produce the least amount of the product is called the limiting reactants. So if they should ask you which of these reactants are the limiting reactants, magnesium is the limiting reactant. So you can see that magnesium is the what? Is the limiting reactant. I the limiting reactant. You see that magnesium is limiting reactant. Of course, this guy HCl produces the highest amount of the product. Do you understand? Any species that produces the highest amount of product in a chemical reaction is called reactant in excess. Hope you understand. So HCl is the what? Is the what? Reactant in excess. So we can see that HCl is the reactant in what? In excess. Do you see that? So with this calculation here, I've got what the mass of H2 liberated in the chemical reaction. I have known what the species or the reactant is the limiting reactant. Number 3, I have known what the reactant in excess. Hope you understand this here. So these are key things you need to understand. Different textbook what different what explanation. Do you understand? But if you want to understand that method here, I've done a complete PDF guide on how to show you how to solve these things here. So if you want that complete guide and PDF, leave that message that you need a complete guide and PDF for this, so that you can use it for your personal study. I want to ensure that you understand this thing properly. Do you understand? So that is for this one here. So that is for the first one here. Now we are still going to use the same approach for question 3. We're using the same approach for question 3. So now let's look at question 3. So now let's look at the last question, because I don't want this video to be too lengthy. This video is already too lengthy, right? But if you need a complete PDF, like what I said, leave a comment section that you need a complete PDF that explain every single thing here I'm teaching you. You understand? So you use that as a personal guide and as a personal study. Do you understand? I just want to give it to you for free. So let's solve some here. So at STP, how many liters of hydrogen will be obtained from the reaction of 500 cm3 of 0.5 H2SO4 with excess metal? With excess metal. So now it's very easy. This particular one is very, very easy. Solution, right? So whenever a question is being given to you, first of all, understand the mind of the examiner. Understand what the examiner is trying to want you to get. How many at STP, how many liters of hydrogen gas will be obtained? Just so from a reaction of 0.05 cm of 0.5 H2SO4 with excess DCF. So now what are the reactants? The reactants are what? H2SO4 and what? Zinc and zinc. So before you solve any question, therefore write out a balanced chemical equation. Do you understand? So the balanced chemical equation here is going to be what? Zinc plus what? H2SO4. Right there. Now here we have zinc metal. The oxidation state of zinc metal is 2. So you're going to be what? Zinc XO4 plus what? Hydrogen gas. That is it. So this one is the balanced chemical equation. So but now let's look if it's balanced. Yet it is what? Balanced. 1 zinc, 2 hydrogen, 4 oxygen, 1 sulfur. Do you understand? So it is already what? Balanced, right? Now what they say should look for? They say should volume of what? Of H2 at what? At STP. What they say should look for, right? What they say should look for, because look at it. At STP, how many liters of hydrogen gas will be what? Obtained, liberated. So they're asking you the volume of this stuff at STP that will be liberated. Hope you understand. Please try to understand this question. If you don't understand this question here, there's no way you'll be able to solve it. You understand? So volume of H2 at S, this what they say you should look for. Now they wait for that to give us volume of H2SO4. So volume of what? H2XO4 is equals to what? Is 500 what cm cubed. Do you understand? Now the molarity concentration of what? H2XO4 is what? Is 0.5 what? Molarity. Now whenever you see molarity and volume, always convert what? Cm cubed to what? To dm. Do you understand? So you divide this one by what? 1000. If I should divide by 1000, I'm going to get 0.5 what? Liter. 0.5 what? Liter. That is it. So the idea now, please pay attention. The idea is to look for mass of what? Look for the mass of what? Of H2SO4. That is what is the key thing. So we'll look for mass of what? H2SO4. So how do we calculate the mass of H2SO4 from these two parameters given to us? Remember, I've given you a formula that is what? Mass over what? Molar mass equals what? Concentration times what? Volume, right? It's okay. So if I should what? Make mass the same formula here, just like the way I did with the first calculation here, it's going to be what? Mass going to be what? Mass equals to what? Concentration times what? The molar mass times what? Volume. Do you understand? That is it. So to do what I'm going to use to work out what? In the sense that this concentration, this volume and this concentration gives to me for what? H2SO4. I have to use to work calculate what mass of H2SO4 for me to be able to do the work calculation. Do you understand? So if I should do that here, if I should impute first, let's calculate molar mass of H2SO4. So molar mass of what? H2XO4 is equal to what? 1 times 2, right? Plus what? 32 times 1 plus what? 16 times 4 is okay. Now, what am I going to get? 1 times 1 times 2 plus 32 times 1 plus 16 times 4. So you have what? 98 gram per what? Per mole, right? So mass, so you can say mass of what? H2XO4 is equal to what? Concentration is what? 0.5, right? 0.5 times. Now molar mass is what? Is 98 times, right? Then the volume is what? 0.5. So what am I going to get? 0.5 times 98 times 0.5. Here we have 24.5 what gram. That is it. 24.5 gram. Do you understand? So that is, I want to wipe this place out now. Do you understand? So I've used this and the molar mass to get what? The mass of what? Of H2SO4 that will react with excess stuff here. Do you understand? That is me. So if I should wipe the board, then wipe this place out. So mass of what? H2SO4. Is it H2SO4? Yes. Mass of H2SO4 is equals to what? Mass of H2SO4 is equals to what? Is 24.5 what gram. That is it. Hope you understand. Now, for we not to waste our time, our focus is going to be this guy and this one here. Is okay. That's what our focus is going to be now. In the exam, they didn't give us mass of this one here. They didn't say anything about this one here. You understand? They only gave us volume. They only said we should calculate what the volume of our H2 that will be liberated or that will be formed when this react excess of this one here. Do you understand? But you know I've got this one here for the value given to us, right? Now, in the sense that if you want to write out your balance mole, balance mass, and balance volume, You only need to pick these two things here. So what you want to do here, in order for you not to waste your time, you're going to have H2XO4 giving you what? H2. Do you understand? So we pick only these two things here. So here we now have what? Mole. Here we have what? Mass. Here we have what? Volume. Do you understand? Now, because they are talking about volume, do you see that? How many more do you have here? Here we have 1 mole. 1 mole. How many more do you have here? Here we have what? 1 what? Mole. It's okay. Now, mass is going to be the molar mass. And the molar mass of what? Of H2SO4 is what? 98 gram per mole. Do you understand? So 1 times 98 gram per mole, here we have what? 98 gram. Is okay. Here we have what? 2 what? Gram. This is that. Now, what is volume? Remember, volume at STP is equal to 2.4 dm3. So 1 mole of any substance at all is equal to 2.4 dm3. Now, so how many more do you have here? We have 1. So the volume is going to be 2.4 dm3, right? Here we're going to be 2.4 dm3. Do you see that? Right? So now if you check it very well, right? Now, they say you will calculate the volume of H2 when we are giving you mass of what? Of H2SO4. So it's going to be this mass of what in the balance equation here. Do you understand? So it's going to be 98 gram of what? Of H2XO4 is equal to now they say should calculate the volume of this one here. So I want to use volume, which is called 2.4 dm is equal to 2.4 dm cube. That is meaning. Hope you understand. 2.4 dm cube. So it is saying that 98 gram of H2SO4. Why? Because we are calculating what mass of H2SO4 is equals to 2.4 dm cube. Because they say she will calculate the volume of what? H2 at what STP. Do you understand? So this way we are now going to do what final what calculation. How do we do the final calculation here? You're going to be what? Remember, we are calculating what volume of what H. So we're going to be question mark volume of what H2 is equals to. Now here we have 24.5 gram of what? Of H2XO4 over what? 1 times. Of course, this one of what? H2. So it's going to be 2.4 dm cube of what? H2 over what? Over 98 gram of what? H2XO4, right? So that this guy will cancel out what? This one here. So what do I have left? 24.5 times so 2.4 dm cube of what? H2 over what? 98. So what will be the answer here? So the answer here is going to be 24.5 times 2.4 divided by what? 98. So here we have 5.6 what gram of what? Of H2. That is it. So this video is already too lengthy, but at least I'll be able to give you a good foundation on stoichiometry what calculation. So please go through this video again, go through this video here and try as much as possible to solve question yourself. Now use this method I've taught you here and master it. Now once you master this here, I bet you'll be able to solve every single questions you see in your examination. Do you understand? So your own is to practice. What is wrong with so many students is that after they finish learning, they are too lazy. They never go practice. I will urge you, I will urge you, and I will tell you, practice make permanent. The more you solve, the more you calculate, the more you engage, the more you solve questions, the more you get this here. So what makes me to be very, very good when it comes to chemistry is because of my daily calculation, daily solve, daily learning. Do you understand? So once you are doing this thing every single day, you find that this that is more complex now, more easier for you. Do you understand? And what I actually say is that students are becoming very, very lazy. So for you to be able to watch this video this time, it shows that you really want to learn and keep it up. Do you understand? So this is what makes to be astounding because it's not easy to learn up to this point. If you learn up to this point here, look at this, leave a comment section that you learn up to this point here, and I have a free gift for you. Just that because I know that it's not easy. If you learn to this point, as I'm saying now at the end of this video, leave at the comment section. Do you understand? As a matter of fact, send me a DM with this number 07037627429. It's okay. My name is Kem Chris. It's okay. Send me message on here. I'll be free gift for you. Just say you came from YouTube from stoichiometric calculation, because I know how lengthy this video is. Once you can stop this time, I will have something for you. So if you need the PDF, leave my comment section that you need what the PDF. Do you understand? If you still don't understand the calculation of more concepts, do you understand? Check out this video that we explain to you. Thanks for watching. See you in the next class.